After you build a few ships and vehicles by hand, and perhaps destroy them, folks pretty quickly learn how to capture blueprints of their favorite ships, then use the projector to cast the image and greatly speed the construction process. But it's still by hand, or by a welder ship. But I'm going to show you a rather unique way to build a 3D printer for your ships, and without having to use hundreds of welders. Printing ships with a projector has been around for a while in space engineers, and most designs fall into one or two methods. Either you project your image and slowly move a wall of welders and construct the ship behind the moving welders as the wall moves, or make a fixed wall of welders and drag your projection through the wall and construct the ship as the projection is moved. Both use a wall of welders. Both methods work, and I'm going to go over at least one reason why most folks use the wall of welders. But both methods apply a brute force approach to printing a ship, rather than engineering.
I'll fix things.
I know what is engineering.
The bigger the ship, the more your welders multiply. And it's pretty easy to get a 10 by 10 welding wall that will add up to 15,000 PCU. Not to mention all the conveyors, materials, and possible performance hit. On a server with strict PCU limits either for individuals or factions, every block counts. And there's also nothing more satisfying than to build an incredible piece of machinery that moves and orchestrates an activity in space engineers. So I'm going to show you a rather sleek and compact welder assembly capable of producing some pretty large ships. First, let's lay some groundwork about the welder blocks so we understand why this build needs to operate the way it does, and why folks build the welder wall. What I'm showing here is a landing platform for one of my ships that also serves as a 3D printer. You can see I have the welders spaced rather far apart, every third block, not even a checkerboard. And in a fair number of cases, this will successfully weld up a large grid ship. But it has flaws, and this is why. I'm overlaying that welder arrangement with a game grid. You can see the large grid blocks laid out, and inside those are the small grid blocks. A large grid block occupies the same space as a 5x5 grid of small blocks. My welders are spaced every third block, and the range of a large grid welder is 4 small grid blocks from the tip of the welder. True, the welder range does touch a portion of each large grid block, which is why this spacing can work somewhat, but it leaves a lot of area potentially missed by this welder spacing. Even if we went to a checkerboard pattern, it still leaves a single small grid block right in the middle. Now, you might be thinking it doesn't matter because there's so much of the large grid area covered by the welders, it's going to get hit. But that's not really true. There are a number of important large grid blocks where the welding area only occupies that one small grid space, like interior lights, sensors, cameras, sound blocks, and a few others that would be missed by this checkerboard arrangement. Which is why people go for the solid wall of welders. It completely eliminates that possibility and ensures full coverage without having to even think about it, and puts more welders to that task. So what we're going to do that keeps our welders more spread out and also allows us to use the area for more than one purpose is to create a kind of oscillator for our projected ship. I think I prefer the general idea of moving the projection as the ship is built, rather than moving the whole welder array and conveyor system. Essentially, the primary direction the ship's projection will be moved is up. As the projection is raised, each subsequent layer underneath will be built. To ensure coverage of the empty areas between the welders, the projection will undergo a kind of oscillation or movement to cover the 2 full blocks forward and 2 full blocks to the side, thereby ensuring coverage and obtaining the same result as the welder wall. The most compact and perhaps visually entertaining way to accomplish this is with the hinge. A small array of 4 hinges will provide full extension of the 2 blocks we need with pretty much a single orchestrated movement. For ease of setup, place each of the 4 hinges with the lower limit mark facing the inside of where the hinge will bend. Place them in a simple U pattern. You can then set the upper limit on all of them to 0 degrees, because that is as far as any of them need to move. Leave the lower limit set to 90. You're going to want each of them to move slowly, but at the same rate. I'm using 0.5 RPM as my speed. The 2 hinges attached to the blocks will start with a positive speed, and they'll be folding in. The 2 already bent at 90 degrees will get a negative speed, as they will be unfolding out. Part of this will already be set up this way because you had to set the hinge either straight or bent to get the U shape, so it's a little foolproof. To activate the mechanism, you just group them all together and hit reverse. The whole assembly will just unfold. Pushing the block, you'll attach the projector, the ship projection, and an attachment block to the ship you're welding out. And it'll keep the orientation of the projection exactly like it started. To collapse it back, you just hit reverse again. Easy peasy. So that takes care of one direction we want to move our projection. To move it in the other direction, you simply add another block on top of the one that was moving and repeat the same setup of 4 hinges to end in another block. Now, to keep Clang happy, I'm using the blast door blocks that have 2 sides of the block shaved down a little. This way, when the blocks are fully collapsed, they're not touching and banging into each other. The fact that the hinges themselves are a little shy of a full block as well allows them to move past each other when they're stacked on top of each other, without any problem. The whole thing is set on 2 or 3 pistons, however many you think you'll need to create enough vertical height to print your ship. This hinge array, when collapsed, also only takes up a 3x3 block of space. So you could pretty easily collapse this whole mechanism down under the floor and have some sort of hangar door or other opening mechanism to bring it up for use. For me, I decided to move the oscillating array in a zigzag pattern. First, fully extending to the side, then moving 1 block forward, moving fully back to the original side, then completing the forwards extension before moving back again to the far side, then making its final journey back into a fully collapsed state. From here, you could set up button commands to activate each step manually, or automate it. I decided to automate it, and did it with 6 timer blocks, 1 block for each of the 6 movement positions during the operation. The timer blocks are pretty easy to set up, but you do have to do a little pre-thought on the timing. I had my hinges set to move all at the same speed, 0.5 RPM, or half a revolution per minute. Now, if a hinge could go all the way around like a rotor, that means it would take 2 minutes to do a full revolution and go completely around. I only need each hinge to do a quarter turn of 90 degrees. So a full extension or retraction in any direction takes 30 seconds. To get it to move 1 block, you might think it would take 15 seconds. But the way these kind of mechanical rotary extension things work, it's not linear. It starts faster and gets progressively slower on some sort of curve. Now, I'm not a mechanical engineer.
I'm not a mechanic.
To know the exact formula, but intuition told me I could break the extension into thirds and be pretty close. 10 seconds of travel would get me to the first block position, and 20 seconds would continue the movement to the end. So with those 3 time frames of 30, 10, and 20 seconds, I was able to set the first timer block to simultaneously start that first full extension and kick off all the other timer blocks at once. The delay on each one was just a progressive addition of each of the movement stages. I just found starting them all at once easier to manage than trying to start each one and then place the delay of the next timer block inside of the previous one, and just all of that. So the movement works. The 3D printer works, because I have printed on it before adding the oscillator. But the big test that still remained with all these hinges and the 3 stacked pistons is, would it support a decent amount of weight to print a large grid ship? So I went through a series of increasingly aggressive tests, but I'll give you the bottom line of where I ended. I stacked out on the end of this long pole 45 large batteries, a total weight of around 175,000 kilograms, which is 3 times the weight of my largest big grid mining ship. Things were a little springy, so I carefully changed some settings. I added the inertial tensor setting to all 3 pistons to stiffen them up, and that worked fine. Then I tried at one point to add the shared inertial tensor to all 8 of the hinges, but that resulted in some strange behavior. The hinges kind of squirmed around, even when not activated for some reason. It was really weird. So then I tried only adding it to the 2 center hinges for both of the sideways and forward movement, and that improved things quite a bit. Then went ahead and added the inertial tensor setting to the 4th final hinge in each of the 2 clusters. That worked really well. I did get just a little bit of wobble, but it was much better than I had hoped, and there was virtually no sag in the arm with all the weight on the end. The whole mechanism still moved well, and to keep all that weight in check, I made sure the braking torque was cranked up to the same as the regular torque, so each hinge would stop when it's supposed to. I might be able to back that off some, but it was all working, so I left it. With the projector now covering every block on the grid, I can also set up a small grid projector alongside this one through a rotor and have it print small grid ships as well. I do like to take a little manual control over when to raise the projection and start welding the next layer, but other than that, it was all automated. Used 1/9 of the welders and allowed me to keep this area as a landing pad, and gave me something really cool to watch as it builds ships. I'm already thinking of ways to even improve this design, and I'm sure there's a lot of variations of these 3D printers folks have made. But let me know in the comments below what you think about this one. I may even try to blueprint it and get it available for download. If you have something really unique, like the springy welders you see during the Space Engineer's loading screen, I'd like to know about that too. Like, subscribe, and check out the Space Engineers playthrough available on the DadSpeed server, where this and other builds are going on. And yes, this was conceived and built 100% in survival in a pure vanilla multiplayer server. Take care, and I'll be talking to you later.